Hi, everyone. Welcome to this webinar on software platform approach for a future-ready utility tech stack. My name is Jay Shah, and I'm the product marketing director for GridOS in GE Vernova's Grid Software. And today I'm joined by Thorsten Heller, who is our Chief Innovation Officer and GridOS for GridOS and Grid Software and the GE Vernova, and also Pim Spirenberg, who is the COO of TRC companies and its EMEA Intelligent Grid Solutions. So let me start off with what is the platform utility, right? So Thorsten, maybe we can start off with your point of view on what in your mind you think that is.
Sounds good, and I hope you can hear me quite well because I'm sitting in the airport lounge in Venice at the moment. I was on a conference the last 2 days where we spoke about the platform utility, where we spoke about data-driven solutions and AI. So I hope the sound is good. But let me quickly start how we define the platform utility, or what the concept of the platform utility is. And to start with that, I think what we should think about is how the grid is developing. And what I mean with that is, of course, we are getting more and more DERs, we are getting more and more assets into the network, we get more and more EV charge station. That means from a utility point of view, you must be able to manage, to operate the future grid, a distributed grid, where you have more and more assets, but where you also have more and more assets you don't know and you don't own. And that means from a grid point of view, from an infrastructure point of view, you should almost think about your grid infrastructure like a platform where you can plug in any kind of a grid asset. And exactly the same is what we need on the software side, on the data side. Because when we think about the future control room, if we think about how the future grid operations would look like, and I'm quite sure Pim can add more things to that afterwards too. But when you think about it, we are thinking about more and more data flows that need real-time data. We think more about forecasting solutions. We think more about AI-empowered solutions, where we really need data from all over the grid, but also external data sources. And that means also from a software point of view, as a utility, you have to think about how can I plug in different data sources? How can I get access to data across the entire network? How can I build this kind of a platform approach? So when I talk about a platform utility, when I think about the platform utility, it's about the capabilities to plug in any kind of an asset and manage any kind of an asset, and exactly the same from a data, from a software point of view, that I can plug in any kind of a data source, any kind of an algorithm or service, but I still, as a platform provider, must be able to manage it. So the platform utility is on the one side for me, from an infrastructure point of view, but also from a software point of view. I hope that makes sense.
Yep, no, that sounds good. Pim, any of your thoughts on this?
No, it's right up my alley in that case, right? I think when looking at utilities, right, and specifically grid companies in this case, and that's kind of a bit of my former life, right? We actually had a lot of discussions about a data-driven utility, right? The way that data is actually playing a role to make educated decisions, right, about the state of the grid. Right? The back office side, we already see a whole loads of platforms, right, with ease of integration, right? But if we move to the OT side of the story, right, focusing on the assets, focus on the grid itself, there is still a lot of ways to go, right? And I completely agree with Thorsten. The way that traditional utilities being set up, right, with clear lines of demarcation between, for instance, asset data, right, grid data, all kinds of operational data, in order to kind of circumvent the challenges that we currently see that's heading towards grid companies, right, at both transmission or distribution levels, across all voltage levels in that case, right, data needs to be shared across these kind of topics, right? So think about your traditional asset management, right? Topics like asset performance management, where you're actually going to utilize sensor information to qualify, do condition-based maintenance, right? Or predictive maintenance, just as one simple use case. That's all going to be based around platform utility in this case, where data is commonly shared between several kinds of verticals within a utility, depending on the use cases that are there. So, all completely important, person said.
Yep. No, and absolutely. I think what hits me is the blurring of lines, right? As utilities think about how to orchestrate and balance demand and supply in a grid where you have a lot more variability in generation with renewables, and you also have some interesting complexities with distributed generation and higher loads on higher peak loads on the distribution side, right? So I think the blurring of lines between transmission and distribution, where you have visibility both real time and look ahead, and then also you can unlock advanced use cases like switching across TND or restoration across TND. I mean, those seem like interesting reasons. And also similar to that, right, the grid to edge blurring of the lines also seems to be an interesting thing for me, right? From a use case perspective, imagine if you can take AMI data into ADMS and unlock a much better power flow. What can that do for advanced applications on the distribution side? It seems like some of these use cases, right, that involve removing silos would be better enabled by a platformed approach versus thinking of it as individual applications or trying to connect all of it together on a point-to-point basis. So that's the one thing that hits me. And then the other one is thinking about grid modernization from a holistic perspective, right? Instead of thinking, hey, I need to replace this application with a newer version or with something else. Instead of that, could you think about it as an entire tech stack from a grid modernization perspective? So that's the other thing that hits me as a platformed approach for utilities, or what they would think about as potential platforming.
Totally agree. And can I maybe add one thing before we jump off? Jay, you already mentioned it. Pim mentioned it. What is important, I think, is to keep in mind, as a utility, you are responsible for resilience in the network, for the stability to manage the grid. Whatever asset, whatever is happening in the network, you are responsible. So you need this kind of a platform approach on the grid side, but you also need it on the software side. I would almost say, and now I'm of course black-white, there is no other possibility, there is no alternative. We have to think about a platform layer as a foundation anyway. So there is no alternative.
Thank you, gentlemen.
And I think that's I think that's an interesting topic, right? You start to think more about. Let me rephrase that, right? I think if you look at the OT side from a lot of grid companies, you've always had big monolithic solutions kind of covering most of the use case. I think the complexity in this case, and also the amount of data that's going to be required, right, to actually make educated decisions about the state of your grid, for instance. Right? There will be still traditional pieces, right, that we normally capture under, for instance, ADMS, right, or DERMS, right, that are still there. But I think what utilities are looking for, and that's kind of what I've encountered, right, when speaking to a lot of utilities, mostly in Europe, right. It's a bit of a narrow view in that case, so there's a bit of a disclaimer there, right? But the amount of decision-making power, for instance, to do a state estimation of your medium voltage grid or on specific medium voltage substations, right, would actually require additional components, right, to be developed against that specific platform to fulfill specific needs for a specific region in the grid, right? And I think that platform that we discussed also gives the utility I think the versatility and the flexibility to cope with these kind of topics, right? Myself being based in the Netherlands, right, I speak to a lot of distribution companies over here. Number one topic currently in the Netherlands, and congestion. It's the way to manage congestion on medium voltage levels. Also transmission level and high voltage, right? And the funny thing that we actually see happening is that a lot of the basically three big distribution companies in the Netherlands, the way that they cope with solving the specific needs that they have is actually based upon, we need to actually start sharing these kind of data sets, right, within the silos that we have currently within our utility, right, and within our architecture, right, and they start to develop and bolt-on applications on top and next to the traditional systems that they currently have. I think that's kind of the power that you kind of assume that a platform in that would actually provide.
Thank you, Pim, and thank you for sharing all those insights. Really appreciate that. Let us now maybe bring Pim into the focus and introduce TRC companies and Pim, who's joined us in this presentation. Right? Thank you for chipping in, and maybe Pim, you take a minute to introduce yourself and TRC to the audience.
Thanks. This is kind of a bit of a shameless introduction to TRC, right? I know this is a global call, right? And there will be people dialing in and actually attending the webinar from North America, where TRC is already in household name. Myself, being based in Europe, right, where TRC is a relatively new company. TRC has been here since, I think, in North America since 1969, right? Mainly focusing on the power sector and the infrastructure sector. Right, and recently TRC developed basically a department called Intelligent Grid Solutions. That's something that they started off initially in North America, right, and me together with a small group of people already setting it up in EMEA. Right, and what Intelligent Grid Solutions, that's kind of focusing on the previous conversation, right? What we actually provide is basically we're in the services business, right? So we're doing advisory, consultancy, strategy work, right, on topics around metering, energy control systems. But it's not only advisory and consultancy, right? We actually also do the implementation, right? So it's a business already being set up in North America, right? So we've mainly focused around IT/OT integration, right? OT systems, advanced smart metering systems, as we discussed, so DERMS, grid edge technology, energy control systems such as ADMS or DMS, OMS, and EMS, right? Markets. We're actually developing a GIS practice, and we actually focus on intelligent asset operations as well. So it's kind of much more focusing on the OT side, right, and think about digitalization in that case to provide these kind of services. Together with companies like GE Vernova as well, in further developing this market in Europe. So that's kind of a bit of a shameless introduction. It's a well-established business in North America that we are currently replicating in Europe, right? With a team of experts that is quite quickly growing. I'm really fresh in this case, right? I started last week, Monday. Most of my career actually worked for Accenture, right? So I was responsible within Accenture for the transmission and distribution portfolio in EMEA, right? Kind of in system implementation and consultancy most of my life. And saw a lot of utilities in that case as well. So the things that I'll be telling up here will be made most of my personal experience and the experience that TRC is currently having in this domain. So thanks, Jay. Over back to you.
Thank you. Thanks for the introduction, Pim, and welcome. Look forward to more of these. All right. So now let's get into the core of it, right? Why should utilities think platform, right? There are numerous reasons why that would be the case, and we've tried to compile a few of them on why that would be the case, and we'll dive into some of these things as well. But let's take a look into some of the platforms that exist today, right, in other industries. So maybe Thorsten, it would be pretty awesome if you could, or even Tim as well, if you could talk a little bit about where else and what other domains and industries have you seen a platform approach from a software perspective?
Yeah, maybe I go first. So one of the platform providers everybody knows about would, as an example, be Salesforce. Salesforce is a really good example for a platform approach because they started out as a CRM system, as a cloud-based CRM system, but they developed the fourth platform, meaning they opened up their system, their backbone, and then started developing a platform approach, meaning giving third-party companies the possibility to add bespoke logic or to add innovation. And it's a good example when you think about Salesforce coming from the field of CRM, being the backbone for customer information, providing a platform giving now third-party companies and of course the clients themselves the possibility to add functionality. So Salesforce would be a nice example. And what is interesting when you think about it's the typical approach we are seeing also. You start out from a business case or business use case like the CRM approach, where you are building the 360-degree view on customer data, and then you are starting out to open it up as a platform, and now you can get more and more different use cases. And that is exactly the same approach. We believe we need in the field of utilities, when you think about having an OT, IT, OT data, grid data backbone, providing core capabilities, you need to operate and orchestrate the grid, but then opening up for third-party developers and, of course, also for the clients themselves, for the utilities to build capabilities. So one of the examples would be Salesforce, but you see, of course, also examples from the financial industry. In the financial industry, you have this kind of platform approach. You could, of course, also think about manufacturing. There are several examples. So my favorite example to use would be Salesforce.
And I think a couple of things that strike me about the Salesforce platform is that it provides a single customer view, which is very powerful, right? Imagine having all the customer interactions captured in a single view. And then also the ability to integrate business applications both on a standard and a custom basis also to me struck as an interesting thing when I've used Salesforce in the past as well. And then also the scalability and the security and all those aspects that that platform provides seems to be an interesting thing as well. So thanks for pointing that out as an example, Thorsten. And Pim, any from your side that you've seen that could be good parallels to utilities?
It's a bit of an overall, right? I think if you look at Salesforce, right, what Thorsten was already saying, right, that's very much focused on IT platforms, right? One of the platforms that I like to use as an example, right, is this one, right? iOS or Android, right? Which is the funny thing about iOS and Android is also that it provides also edge device in that case as well. But I think the platform by itself, ease of integration, right, openness, data sharing, right, to actually provide third party to develop applications. I think there's those examples of what's currently being deployed on devices, right? Obviously, right, I think this is pretty much the top, right? If you kind of look what it would mean for a platform utility, right? And I think, but if you combine the things that you actually have, right, on a device, right? Combine that with the examples of Thorsten forward, which is much more centralized. I think that's kind of why you have in the middle, right? Because edge technology, your devices are being deployed, right, with intelligence as well, right? And the platform, right, think it could extend to your device in the field, right? And that makes it really, really interesting, right? And to give an example, right, I worked on a project developing a next generation smart meter, right? It's currently being developed in the Netherlands, right? That is actually taking standards from the UK, right, to the Netherlands, right? And there it's also the platform thinking to actually be deployed on the meter itself, right? And look at the meter much more as an IoT device where the platform extends from a centralized, well, normally a traditional head end, right? The platform extends actually towards the meter itself. And that provides so much more flexibility. The moment that you want to run a specific data application on a specific weather set of meters, provide real-time information back to the centralized system, that's kind of what you need to start thinking about. And for me, that's kind of where I think the combination with Thorsten said on Salesforce, right, and a iOS, Android-like platform as well, the combination is very, very powerful in this domain.
Got it. No, thank you. Thanks, Pim, for that particular perspective as well. And now when you translate that to utilities, right, one of the key reasons to, we have identified 6 or 7 of them, and let's cycle through some of them, right? So scalability and updates for future proofing, right? So as imagine your grids grow, as the number of assets that you manage grow, as the data volume grows, right? Or the number of applications that you are operating grows, you require that scalability and that ability to bring updates for new functionality into the perspective as well, right? So that future-proofing aspect tied to both those things is really, really important. That allows you to scale as needs increase, and that's one thing that the platform can provide. Pim and Thorsten, you did speak a lot about integrating data, right, across the entire ecosystem. That's something that platforms can really unlock as well with the use of a data backbone or a data layer, right? Every platform typically has one of these. And I think tied to it, the other aspect is also interoperability as well, right? How do you enable utilities themselves or third parties to build on that platform, right? How do you keep it open and make it standardized, right? So that things can be built on the platform. Think about it as building customizations on the platform, but buying standard, right? How can it allow that best of blending both of those approaches together? That's an interesting reason why platforms could work for utilities as well. Think about it from a streamlined perspective as well, right? For every application, if you have to manage its IT infrastructure, right? Where do you host it? How do you support it from an IT perspective? Instead of that, if you have a platform, imagine how much you can reduce your total cost of ownership and streamline your IT operations, because everything is tied to a single infrastructure, a single hosting platform, and a single set of IT needs. So that's something which is also interesting as well. Built-in cybersecurity, right, for resiliency. One of the things I really appreciate about my iOS ecosystem that I'm in is how secure it is. I don't have to worry about a lot of different things that I would have to if I was on for example, a browser which is not inherently protected. So that built-in cybersecurity, that zero trust aspect that a platform provides is also a really important thing as well to consider for utilities as they think about platforms. And then both the examples that you pointed out, the iOS, Android, and also the Salesforce, right? The consistency of the look and feel across the applications, right, makes it really easy to operate some of these things, right? Provides a unified UI UX, provides faster workflows because people are familiar with those UX constructs. So it's a lot more consistent in nature as well. And a lot of those aspects make a platform approach for utilities more and more important, right? As the blurring of the boundaries would need to be achieved. So think of a platform as a new tech stack that is also supported by a faster time to value, so that you can get modernization faster, but at the same time you can unlock a lot of these benefits that you see by adopting a platform approach. Any other concluding statements from you, Thorsten or Pim, on this?
Yeah, I want to add two things. Jay and Pim, in the end, you already mentioned it. So I'm just repeating what you said, using my own words. I think for me, the platform utility or platform approach for utilities, there are two main things we should think about. Number one is what you have written on the slide here, time to value. So both Pim and I, we are old enough, we remember the old times. Every time we had a great idea to develop, we had to start from the scratch, had to build our own integration layer, our own security layer, our own data storage, things like that. If I just think about how much time we spend in commodity functionality to build it, and then afterwards also to operate it, total waste of time compared to now. And to use Pim's example, when he spoke about the bottlenecks in the Dutch market, when we are using our platform approach, where the data is already integrated, where we don't have to think about cybersecurity, I don't have to think about scalability, but instead I really can focus on building the smart services I need to manage the bottlenecks, to identify the bottlenecks, or to do the forecasting. So time to value, that is number one, which is extremely important for me when we think about platform. But the second thing I want to talk about or to mention quickly, I do not like the word of total cost of ownership. Because many people, when we think about IT, it's always total cost of ownership. And of course, we want to optimize the operational costs. But we are moving into a new world. We are moving into a distributed energy system. We get more and more AI services. So instead of total cost of ownership, we should think about cost to serve. instead, meaning what is the cost we are having to serve all the new functionality and requirements, and having a platform approach where, as an example, the operational costs are optimized compared to a siloed approach makes totally sense for me. So for me, the two most important benefits would be time to value and then cost to serve, and all, of course, in the context of security, integration, things like that. But in the end, I was just repeating what you said, Jay.
Yeah. Nothing to add, right? I think we've kind of I can reiterate what Thor's saying. When I speak to customers, right, and the burning platforms that they currently have, specifically on distribution side, I think time to market or time to serve, that's the big one, right? The versatility, the flexibility, and the time that it would take to actually develop additional applications in a very complex landscape that the platform actually provides, right? And we already see small examples in that case, right? Speed is of the essence at the moment, right? The challenges that come towards the grid, or not come towards, there are the grid companies specifically in Europe are already in, right? We can examples for in several countries, right? The capacity issues, congestion issues, right? The transition from network to operation, blurred lines between transmission and distribution, low voltage visibility, right? And there are a lot of smart people already employed by utilities that basically can develop these kind of topics on their own, right? But it needs to, and that's what we're able to provide, right? To actually have utilities have their own dev teams, right, with their SMEs, that they can actually sit down together to actually start building kind of smaller applications, data-driven applications, right, to make educated decisions in these kind of topics. So completely. Yeah.
Thank you, gentlemen. All right, so let's then talk a little bit about what does a platform approach mean, right? What are some of the core capabilities that we need to think about in a platform? And I think the simplest analogy to me is moving from thinking about replacing or modernizing individual applications towards more of a strategic grid modernization, right? Replacing your entire tech stack, right? That to me is what it feels like a core capability perspective. And let me take an example, right? So imagine in a siloed application world where you have your own DMS, OMS, SCADA from all different vendors. You're trying to get probably the best functionality that you believe will work for you, right? That would involve having each of those applications having their own data stores, their own UI, UX, their own hosting infrastructure. And think about blurring the lines between all of these applications, right? You would end up in a world that is very point-to-point, many-to-many relationship-oriented. That makes it really complex. And imagine if you end up in a situation where you have to replace one of these things. You have to build all of them again, right? The interfaces between all of them. So it makes it very tricky when you think about strategic grid modernization in an ecosystem where all the applications are individual in nature, right? They're not tied to a platform. And I think that's the benefit of a platform approach, right? It really helps build a new tech stack that can enable grid modernization because you have all these different components, including a data foundation, the UI, UX, built-in cybersecurity, shared services, and a common architecture. It brings it all together to really simplify the blurring of lines between the applications, right? So that to me hits me as core capabilities from a platform perspective. Pim, Thorsten, anything from your perspective on this?
Yeah, I want to add one or two things. And again, Jay, sorry, I'm just repeating what you said. So I'm not adding that much new value today. But when you talked about the blurring lines, when you talk about the new operation models, things like that, then one of the core capabilities we need in the platform is a cloud-native infrastructure. Because as you said, you spoke about blurring lines between traditional domains, but also between different systems. And in the end, what we already mentioned, we need the possibility to manage and orchestrate the grid from the grid edge, from behind the meter, all the way up to the power generation. That means we need an infrastructure, and that would be the lowest level in my kind of a platform thinking. We need an infrastructure that can operate in a hybrid integration scenario. Parts of the workloads are running on-premise in the control room. Parts of the workloads would run in an enterprise IT. Parts of the workloads might run in the cloud. And parts of the workloads and more will even shift to the edge. So the first requirement would be a foundational layer underneath a cloud-native infrastructure supporting a real distributed environment, a hybrid cloud environment. When you now add on top of that, because we are in utilities, so we need a robust cybersecurity layer built into this foundation. And that is extremely important because when we think about how have we developed security in the siloed approach, you can almost think about each of the applications having a bespoke cybersecurity model. But with all the changes in the situation, the changes, more and more cybersecurity threats, we need one model that secures the end-to-end architecture. So the second layer must be a robust cybersecurity framework that we are using across the entire architecture. And then on top of that, you need a data foundation. You need a distributed data integration and analytics platform that builds the data foundation for your operational systems, but also for your analytical systems, that creates the data foundation to train your AI model, to operate your AI model. So that would be the next layer. And then the last layer in my mind would be this kind of a single pane of glass, because the future grid, or when you think about the future control room, it's all about integrated intelligent workflows. And the operators cannot switch between many different screens and things like that. So we need a single pane of glass to provide these intelligent, integrated workflows for the future. So my layering then would be the infrastructure layer, hybrid cloud, cybersecurity, data foundation, a single pane of glass, and that enables then for the utility, the integrated intelligent workflows. That would be my simple approach to it. And of course, now we could, if we want to, go deep dive in each of the layers, but to layer it, these would be the core capabilities as a minimum.
And I think one thing that hits me is the fact that the deployment flexibility, right, that utilities will require in the future, right? The flexibility to deploy on-prem or in cloud, or even at the edge as well, or even in a hybrid environment would be a really, really critical thing, right? As they think about how to get the applications closer to the point of impact that they need to operate at, right? So to me, that the core layer, right, the architectural layer, where it's not just cloud enabled, but it's so deployment flexible that it can be deployed on-prem or on cloud or hybrid or at the edge, I think is going to be really, really critical. And I think that was one of the questions that came out from the audience as well. So I hope we've answered that particular piece. Pim, anything from your perspective to add on to what Thorsten mentioned?
I'm going to a different approach, right? I think what Thorsten is kind of saying, what kind of layers is actually required. But what I'm seeing more and more is the basically focus on functionality, right? It's the modular approach in that case within the application layer, I would basically say. So the security layer, physical layer, right? I think that the kind of where you still have lines of demarcation, right? Eventually at your presentation layer, it kind of reminds me of the old OSI model, right? So the 7 layers in that case, that has been told to me 25 odd years ago, and it's still relevant. The funny thing is, right, what I see more is that the breakdown of the big monolithic systems that you normally see within grid control, right? We conversations about, right, SCADA, ADMS, and DERMS, right, and specifically focus on DERMS for distribution companies in this case, because it is also sort of a black box, something that kind of doesn't exist, right, or EMS, right? You still see these kind of topics kind of moving in, but modular approach, right, because there are specific functionalities. For instance, think about a voltage optimization, right? Think about flow control, flow forecasting, right? Which is going to be important. They also use the similar kind of data sets out of the traditional monolithic system. What the platform approach would actually provide you, saying you should be able to bolt on, right, third-party applications, custom-developed applications, or applications that your traditional OEM is able to provide you, to build a not a fit for purpose, right, product, but a fit for purpose solution dedicated to what you're currently seeing. And I see more and more grid companies in Europe kind of exploring, some actually pretty well, right, saying we're going to create and develop our own modular approach ourselves. Right, but it's kind of fulfilling a need that a lot of grid companies are looking for as well, right? And depending on where it's going to be deployed, right? We mentioned cloud. The moment that you mention cloud on the IT side, it's everybody's going to say, yeah, we need to have cloud in order to process large volumes of data, right? But if you mention cloud in another world, a lot of people have a tendency to get quite nervous about it as well. So topics like sovereign cloud, right, is actually where you need to start thinking, right? How do you leverage cloud-like functionality, cloud-like AI scalability topics, right, to actually start managing large numbers of data, right? Real-time data, data from your historian, right? And there's the blurring of lines again, right? Because normally you have data in your historian in real time for two worlds. So that is eventually what needs to be combined. And that's what a platform approach, right, with specific modules for specific use cases will actually allow you to do.
Thank you, Pim. All right, let's move to the next topic, which is Grid OS, because we're also seeing a couple of questions from the audience touching on this. So maybe Thorsten, if you could take some of the constructs that we discussed before and translate them into what GE Vernova Grid Software is doing from a Grid OS perspective on the platform strategy, that'll be pretty awesome.
That sounds good. So when we are building Grid OS and when we designed Grid OS, we wanted to build a new suite of AI-empowered applications to manage and operate, plan the grid. But what was quite important, and what Pim also mentioned, we didn't want to build, once again, a siloed or monolithic approach. We really bought into the idea of a platformed approach, or now I'm using a new buzzword, composable systems and composable data. Because when you think about what I was talking about, my single pane of glass and these intelligent integrated workflows, you would compose these workflows of composable system, composable data to create in the end the smart way of managing the future grid. So what we are doing with Grid OS is providing a platform approach where we have the core capabilities I already was mentioning, like the hybrid cloud infrastructure, enabling us and our clients to operate on-premise, enterprise IT in the cloud, but also at the edge. But what we also do then is providing with Zero Trust this cybersecurity framework that I was talking about. As part of our platform approach, we are providing a distributed data fabric using innovative concepts like data federation and data virtualization and having this UI UX. And now something important is in addition to that. Because Grid OS is a platform that is built and designed for grid orchestration for utilities. That means in addition to, let's say, generic capabilities like data integration, like cybersecurity, all of the capabilities I was talking about are, of course, heavily optimized for utilities and utility use cases. To give you a simple example, because we don't have the time, our data fabric is heavily optimized to handle huge sets of data, vast amount of data, securely between OT and IT, typical utility charge. But what we also have built on top of that is a set of shared services and applications that you would typically need to serve many different applications or services. As an example, SCADA. We have in GridOS a shared application, a shared service to manage SCADA. And when we say SCADA, we talk about millions of SCADA attacks per second. We also have a shared service, a simulation engine that we can use both for transmission and distribution. And one of the questions I saw from the audience was also related to the modeling, to how we are building in the end the network model, where we are providing as part of our domain-specific, utility-specific platform, where we are providing the model manager, which in the end creates the system of trust for geo-network data. And those kind of applications, that means we are providing the platform, domain-specific, utility-specific shared services and applications on top, and then we are building applications that are supporting the utilities to plan and analyze the network, or to operate and orchestrate the network, to handle the market transaction, but also extremely important, and that makes GridOS special. We designed it as an open platform. So our partners, people like PIM, people from TRC, or the utilities can build their own applications, their own bespoke logic, using our platform capabilities to foster innovation. Hope that makes sense.
No, that makes complete sense. And let me also answer a couple of additional questions that have come up on chat. Yes, the GridOS platform can be installed wherever the utility desires, right? That's the point of the hybrid cloud architecture. If you want it on cloud, so be it. If you want it on-prem, so be it. Want it on the edge, so be it. If you want it hybrid, it can support that as well. So that's something which is a big, powerful hosting capability of GridOS. And then the second question is Geo Network Management GIS? Yes, GIS is included in Geo Network Management. There might be other apps as well, but that's where it would absolutely belong. So good call out on both those things. And Thorsten, you spoke about the fact that a platform approach has to be open to utilities, right? And you spoke about the ability for customers or utilities themselves and our partners like TRC companies to be able to develop and deploy applications, right? And even customize them as well. So from that perspective, Pim, any specific insight from you on what would you expect that open nature of the platform to be?
It's basically, right, providing companies like ourselves, right, to actually work together hand in glove with our customers, right? And I think that's kind of where, and we talk about a lot about blurred lines, right? But I think what we've seen, and this again, right, focusing very much on Europe, right, is that the relationship between utilities and companies like GE Vernova on this domain, right, has been quite traditional. And I think the platform approach by working together with customers, right, different companies such as yourself, right, that is mainly focused on developing not so much on third-party applications, right, but actually do the integration between all the topics in that case as well, right. That gives kind of existence for intelligent solutions as we see TRC is currently deploying, right. And as said, I've got a large background in integration. I've been part of a joint venture between an OEM and a system integrator, right? So look it up on LinkedIn if you're interested, right? And in that case, right, that market is there, that demand from utilities is there, right? For companies like TRC to work together with companies like GE Vernova to actually provide that, I guess, tailor-made solution any customers in that case looking for, right? And I think it's what a platform is able to provide in that case is again that flexibility, that shorter time to market, right? Reduce cost to serve, right? All the topics and interoperability, right, around SIM-based information models, right? Integrated security, but actually quite quickly develop together with customers the way that these kind of topics need to be solved. Right, so for us, it's the main reason why TUC has actually stepped over saying, no, we're going to do in Europe as well, right? I think there's an established market in the US, right? TUC is quite strong in that case, right? And we like to believe, and that's something that we're developing, but that we are able to establish a similar kind of market, right? Working together with companies like GE Vernova to actually tackle these kind of topics, right? And that's why I'm very happy to actually be participating in this webinar, because this is right up our alley. This is kind of what where we believe where the bigger play actually for companies like ourselves.
No, thank you, Pim. Thank you, Thorsten. All right, let's get to the next topic, right, which is so important from a platform adoption perspective as well. So maybe, Thorsten, if you can kick us off on how a platform actually enables adoption of AI by utilities.
Yeah, I would turn it around. I would say, and that was something, by the way, I mentioned in the beginning that I was on a conference the last 2 days where the main focus was AI. And as part of the conference, we had a workshop, we hosted a workshop where we spoke about AI maturity model, and we also discussed the different pitfalls we are seeing. One of the #1 pitfalls that our clients and our partners identified, and when I say clients, I mean, of course, the utilities, is the data, having the data foundation in place. What it means is there are so many AI pilots out there that never make it into production. And some of you have heard me before. There's a statistic out there saying still 80% of all AI pilots ending up at the POC graveyard. The reason for that is the availability of good data, of structured data, of data that is organized to feed the training data to the AI model, but that also feeds afterwards the trained models with operational data. So to turn it around, it was a long sentence. What I try to say here is, I'm a big believer that without a platform approach, we will not be able as utilities to really benefit from modern technology, from emerging technology. We might not, or we will not be able to build these AI-empowered services we need in the future to operate the grid. So having this platform approach with a distributed data fabric empowers the AI services, because the platform will provide the good data foundation you need to train the model, to operate the model, and of course, continuously retrain the models. And the last important element also, it's about validating the model. And that is why you need, at least I believe it, and I'm again quite bold about it, you need this platform approach if you want to run AI-empowered grid orchestration. Hope
Thank you,
that
Thorsten.
helps as a starting point. Yeah.
Thank you, Thorsten. That's really, really helpful. Pim, anything to build up on what Thorsten said on this topic?
It's I wouldn't go as far as to say that a platform is a prerequisite to actually use AI, right, and start learning and actually start thinking about learning models. It definitely makes it easier, right? The way that the platform is being deployed, right? Talk about all the benefits that we just talked about, right? The way to actually start utilizing new technologies such as AI, right, and the way that it's actually moving up, right? The same goes with cloud computing, right? A platform kind of facilitates that easier, right? But I wouldn't go as far as Thorsten, and Thorsten is much more an evangelical than I am when it comes to the platform. It makes it definitely easier, right? And I think it actually comes down to the ease of integration, to actually make the data available for the platform to actually start studying and actually start learning your models, right, and validating your models, right? If it's encapsulated in big monolithic systems, right, it's pretty hard and also sometimes even impossible to get that data out, right? Or it has a lot of custom integration. I think that's kind of what I'm saying. Sure, platform actually makes it easier in that case, and I think there's already in the case in the chat as well that just come in. So how the platform will help validate the AI model. I think the platform by itself doesn't, right? Way the data can be made available out of the grid control systems to actually start training your models, right, and validating your models. I think that's kind of, so I look more into the ease of integration and data proliferation within the architecture that the platform is facilitating.
Got it. No, thank you, Pim. And a couple of things that also hit me as well, right? One of the core things around AI technologies and models is that they require a modern tech stack, right? Microservices-based, containerized applications to ensure scalability, right? Because some of these AI applications do need processing power and do need a decent amount of storage as well, and they need to scale up and down tied to that. So having a modern tech stack that can reflect the nature of many of these AI models and how they function is really critical, and that's something that a platform approach can provide to utilities. And the other thing is, how do you also embed these AI capabilities into the platform itself so that you can make the applications lighter, right? Instead of having to build this into every application. So to me, that's the other thing that also hits me as why a platform approach is quite important from adoption of an AI ML perspective, not just the data backbone to help it training and good input data, but also setting up these things for success from an infrastructure perspective as well would be a critical thing as well. So that's the other thing that actually hits me on why platform for AI. All right.
Yeah. Can I add something?
Yeah.
Can I add something, Jay, before you move on? Because there was also a question from the audience related to that, and Pim already started to talk about it. It's about the validation of the AI models. That is an important thing I want just to go back to. And of course, Pim and I, we had many discussions about the platform utilities. We have done these discussions for the last 6, 7, 8, 9 years. And he knows I'm a simple mind, black, white, you need a platform, simple mind. But to come to the validation part, there's an important thing, and that's why I'm a big believer in the platform approach. To validate the AI models, what we have to do is we have to create transparency so the users, the operator would understand how the decisions are made or how the proposals are made. And that is where my platform approach comes in, because in, let's say, 5, 4, 6, 7 years, we're going to have a series of AI services where the services are using different kinds of technologies underneath. To create the trust in the AI model, we must provide a transparent model that helps operators to understand how decisions are made, what kind of quality of the data was used, how insight was created, and to unify it and to enable us in a holistic approach for all the different services. Again, the platform approach comes in. So to validate, the first step is to create, in the end, the trust. Sorry to come in with that, Jay. Yeah.
Oh, no, that's perfect. Thank you. That is excellent. All right. So the next set of use cases for a platform in our mind is to really help speed up your grid modernization journey, right? So Pim, maybe you can talk a little bit about how this approach can help utilities get access to better, to stronger functionality faster. That'll be pretty awesome.
I think it's kind of reiterating, right, what I've been saying, and now it's actually being captured in one slide. Right? If you look at the utilities and system integrator, right, and in fairness, right, this is currently where a lot of utilities actually are, right? And if you, and I'm not going into OS, because that's kind of what GE is actually good at, but if you look at the number 1 and number 2, right? I think the ease of integration is showing in that case, right? What I'm interested in is actually how to facilitate, how to go from your real-time systems, right, and the applications that are there with a point-to-point integration point, how to actually make the transformation from picture number 1 to picture number 2, right? And I think if we have these kind of conversations, and it's for people that have been living most of their time in IT, right? This is like bread and butter, It's kind of saying this is how integration works, this is how data fabrics work, right? This is kind of how we implement it, right? But in the OT world, this is still quite new, right? And it's a pretty big change case on actually go from sharing data between several monolithic applications, right, to actually have a data fabric, a data platform as an integration platform in that case. Right, but the value in that case from these data and integration layers have been proven, right, already a decade ago, or right, more than a decade ago in the traditional back office platforms at a lot of utilities. Right, how GridOS can actually work as a solution aggregator, I defer back to you guys, right, Jay and Torsten, because this is kind of your baby. But I think it's for us, right, coming back to TRC, right, it's we're already doing a lot of work, right, in picture number one, which is already a lot of work in case that is doing themselves. To make the transformation from picture number one to picture number two is also a lot of work that we really see that we already consider.
I think the important thing is, Tim, and you already said it, when we are moving into the platform utility, we are not talking about a big bang approach. That's not what we are talking about. What we are talking about is, in the end, and that is the step number two, what Jay is showing us right now is where you are implementing a platform, you make the data from the existing applications available, and now you are starting to create value, building your own reports, where you are running your own AI models, where you are building bespoke logic. And then when you have the platform approach in place, then you can start moving over and say, now I start modernizing my existing underlying infrastructure. So I think the important message is we are not proposing to say, oh, here's your existing landscape. Now we make a big bang and now suddenly you are platform utility. We all know that's never going to happen. It's a journey. And that is what we are providing, where we are saying, as a utility, you should get started with a platform approach today. Use the existing applications, use the data, start building bespoke technology, get experience, get the skill sets you need to operate a platform, and then afterwards, you can start modernizing. And that is what is here called GridOS as a solution aggregator, because you get more and more modern applications to orchestrate the grid. You can start modernizing or retiring existing functionality, but in parallel, you are building more and more new services, own services. And there was a question from the audience, can we bring our own model or create custom models? Yes, you can also build your own AI models, your own AI services, and the underlying platform will feed your models, your bespoke models also with the training data and the operational data.
Yeah, and one other thing that also hits me, right? If you are integrating your applications or your constructs from a point-to-point, many-to-many perspective, imagine having to replace one of them. You have to rebuild all those interfaces again, right? So instead of that, and as Torsten mentioned, it's not a big bang, right? You're probably going to bring in new functionality and you're going to phase out old functionality, right? How do you do that? Having an abstraction layer with a data backbone really allows you to do that, right? Because it connects all these things in a simpler way, and it allows that replacing that old one and bringing on the new one easily, and not having to disrupt the entire application ecosystem because of that. So to me, that's the summarization, Torsten, Pim, if I may, on why a platform approach can actually help with grid modernization journey, because it really provides that transition a lot more ease of transitioning versus having to do a rip and replace or a big bang kind of a thing. It allows you to maintain your business continuity while allowing you to bring new modernization functionality to the mix as well. So to me, that's what hits me as really important.
Yeah.
All right. So,
and maybe Jay, one quick comment. When I spoke about existing applications here, I was not talking about GE Vernova applications only. Of course, the model I was talking about is also meant to handle the platform, or to make a platform approach available to utilities running non-GE applications or third-party applications too. Yeah.
and that's the benefit of having an open platform, right? Wherein you can bring in your own applications to the mix as well, even if they're not GE Vernova.
Cool.
Right. So I know we're getting close to time. So Thorsten, maybe you can kick us off on how do utilities get started with this journey?
So one of the things, and that is, I can make it fast because I think most of the things we already spoke about. The important thing, the platform utility is not I don't want to call it a project or implementation, it is a journey. And as part of the journey, one of the things that I'm always asking utilities is, think about the future operations model. So if you are starting the platform approach, you should today already think about how the future operations model is going to look like, because that is why you are building the platform. You are building the platform for the future operations. So start to identify, think through, envision the future operations model, build a dedicated team that is focused on it, and then start to build your roadmap, get the platform in place. And now we are getting back to what we already said. Use existing applications, integrate the data from the existing applications into the platform, build services, get experience, get knowledge, and then start modernizing. That is the approach to do. And as you said, we are running, unfortunately, out of time, as always, when we are discussing. So I'm sorry about that.
Yeah. No worries. Pim, any concluding thoughts from you on this before we get into Q&A?
I'm just going to use this as a kicker. Get started, call me, so we can help you. But I think Thorsten is the nail on the head, right? It's a journey. And a journey is something, right, and that might sound weird, right, in a GE Vernova webinar. This is fantastic, right? It's basically transformation decades and get the platform in place, right, and make sure that you have a clear roadmap on where do you want to go, right? This is definitely not big bang. It will take years. It takes a lot of acceptance in that case as well, right? In a very traditional part of the utility as well. So it by itself, it's not a project, it's not a program, it's a journey in that case. It's a big transformation.
All right. No, thank you. Thank you so much. So with that, we've come to the end of the webinar. We'll jump into Q&A. I know we have a lot of questions, and let's spend maybe 5 minutes on some of the questions that we haven't answered, right? So one of the first ones that I see on the docket is this might be for Thorsten, right? Is the AI ML agentic AI approach, or is it an AI agents approach from an AI perspective for our models? Maybe I can respond to that. The way we are thinking about AI models on GridOS is it's really use case dependent. Yes, there will be certain use cases that are more LLM oriented, AI agent oriented, but there will be many use cases that are more computational or statistical in nature. And depending upon the nature of the use case, we will have the flexibility to bring in whatever AI model or agent oriented approach that you would like to bring. So I think that's a key thing over here. Let's go to the next question. How existing DMS data from different vendors can be integrated or migrated to the platform? Really important question because platforms inherently need to be open so that utilities can bring in any applications that they want. Of course, we would prefer the native interoperability that GE Vernova applications would have with the platform layer. But if you have your own applications, those could also use that open nature of the GridOS platform to build on as well. So absolutely. Next question, Thorsten, for you. How is it compliant with some of the IEC standards, right? 61970, 61968, and 62325?
Oh, I can give the short version now. Interoperability with ESA standards and other standards is one of the core design principles. Wherever we have standards available, we try to leverage the standards. But all of these standards have, of course, a lot of different variations. So it's a detailed discussion. And We are working at the moment on a detailed list describing exactly which kind of standards are supported in which levels of the application or technology stack. So that is something we can provide. Yeah.
Absolutely. Thank you, Dorsin. Next one, when referring to edge deployment, what hardware and operating system components of a digital platform, what kind of a combination is expected, right? So I think it's the interface between hardware and software, and how would we potentially define it or prescribe it, I guess.
Yeah. So technically, we have two different approaches here, but that is also a detailed architecture discussion where we should maybe set up even a separate webinar, because the entire grid edge architecture is a topic that we could discuss for endless time. There are two different models, because there are cases where you have a grid edge device already available, might be from a third-party provider, might be an edge platform, where our focus from a platform point of view is to manage these devices and exchanging the data. The second part is we can run parts of our workloads on these simple devices out there. So what kind of hardware OS combinations is also something we can provide.
That's all the questions that we are seeing, considering that we have run out of time. So thank you so much, and really appreciate all your engagement and all the questions that you've had, and allowing us to respond to some of those as well. So thank you everyone for your time.